So we're finally up to the last place where sodium can be reabsorbed in the kidney, and that's the collecting duct. So let's take a close look at that. So the collecting duct is a little more complicated, mainly because there's more than one kind of cell that lines it. So here's one kind, and then here's another, which we'll draw a little smaller. And on this side, maybe we have one and then the other. Now the two kinds are principal cells, that'll be a principal cell, and intercalated cells. And actually there's two kinds of intercalated cells. There's alpha and beta. But for sodium reabsorption, it's really the principal cell that we care about, and so that's what we're going to talk about in this video. So how do principal cells work? By now you could tell me the first part. It has a sodium-potassium ATPase on the basolateral side. And then on the apical side, what does it have? Well, finally we get a break. On the apical side, it has a simple channel that just allows sodium through. And it has a nice name. It's called an ENaC. And that stands for Epithelial Sodium Channel. So the sodium concentration is very low inside the cell, and that's because of this pump over here, and that causes sodium to diffuse in through the ENaC, and so sodium's path through the cell looks like that. Now what about potassium? Potassium, as usual, needs a way out because you keep pumping it in, and so it can go out through a potassium channel on that side, and it can also go out through a potassium channel on this side. So that means that instead of just kind of going in circles here like potassium was doing in some of the other cells, here some potassium can also actually cross the cell in that direction. So that means that these principal cells can reabsorb sodium and they can excrete potassium. Now we're going to talk about potassium later on and how the body deals with it, but it's a good thing to notice for now. Now a while ago we mentioned that if you have high sodium intake, you want to excrete more sodium. And we mentioned that it's the distal part of the nephron that does that. And in particular, this ENaC channel is really important. The idea is that if you have a very low sodium intake, your body is going to make sure there's a lot of ENaC channels here on this side of the principal cell. And that way sodium has no trouble getting back into your system. Whereas if you have a high sodium intake, you're going to have a reduced number of ENaC channels so that you don't reabsorb as much sodium and you can excrete more. But that's just a little bit of a spoiler. We're going to talk about all the mechanisms for how that happens in the future.